this time we're going to have two repositories, because we have two copies. Like one is the one that is on GitHub, and the other one is the one that we have locally. Okay, so let me do, I don't know, I'm going to try to draw a line, and it almost works. All right, so everything above is going to be GitHub, right? So I'm going to say GitHub, okay, and over here everything is going to be local. Okay. Now, so what did we do? In the beginning, we went to GitHub and we clicked, create a new repository, and then we marked a couple of checkboxes. We said, okay, create a README for us, create whatever a .gitignore for us, create a couple of files for us. Okay. So what happened on GitHub was pretty similar to what we just did. Okay. So there was some initial state, and then it created a commit, which the message of the commit was the initial commit. Okay, I'm going to call it ABC1. Okay, so same thing, like all of this stuff, it kind of happened. It kind of happened over there, pointed over here. Okay, so it had its own. It had its own, main. And by the way, I can zoom out a little bit. Okay, like this. Let me actually try to move this a little bit. Okay, so it had its own, main, and it had its own head and all of these things, same as before. Had. Okay, so this was the initial commit. Okay, then we went ahead, and I'm gonna move this around a little bit, maybe like this. Okay, then we went ahead and we said, git clone, and git clone, well, pretty much recreated all of that, but more. Okay, so git clone did this. Okay, same thing, and we have like the ABC1, and we're gonna have this, and it points back. Okay, now a very important thing, we're gonna have main over here and head as well, but these are not these ones, main and head. Okay, so what we're gonna have is we're gonna have the main. Okay, main like this, and then we're gonna have the blue. We're gonna have the head. Okay, like this. And now, because every time we do git clone, behind the scenes, Git actually does git add remote origin and whatever the link to this GitHub repository was, then it actually, we're going to pick red, well, red. And what it did was it copied like sort of like these pointers. Okay, it said, okay, at this point in time, there was also origin slash main, like this. Okay, and also origin slash head. Okay, great. So what happened next? What happened next was that we created our own branch. Okay, so let me move this up a little bit. Okay, so we went and we created our own branch, and we called it fix or feature branch, something 1337. I'm not going to write all of this out here. I'm simply going to call it topic, because this was a topic branch where we were supposed to work on a feature or something. Okay, so what did we do? We said git branch and the name. Okay, so we did this, and I'm going to call it topic. Okay, what did we do then? We said, okay, git checkout topic. Okay, why? Because we wanted that our head would just point there. Okay, like all of these things, they're pointers. At any point in time, you can say git checkout and use any of these names. Okay, so we move the head, which means I need to remove it. Okay, from here. Okay, and notice that already, like even though we haven't done any commits, we're already divergent from whatever happened there. Okay, and on GitHub. Okay, let me maybe zoom out a little bit more, maybe like this. Okay. Great. So what did we do then? We went and we created a couple of commits. Okay, so let's do, I'm gonna draw them like a little bit below. I'm gonna do like, okay, so we did like ABC2, ABC3. This is enough. Okay, so it was like this, and it pointed over here, and it was like this, and whoops, and it pointed over here. Okay. So, because we did this couple of commits, it means that we move. In fact, every time I move something, I'm gonna draw it first, and then I'm gonna remove the previous one. Okay, so the topic is now here, and the head is now here. Okay, head, right? And because head points to topic, it means that we're on the topic branch. If you want to go with this other metaphor. All right. Now, what happened next? The next thing that happened was that we pushed this branch upstream. We said, okay, we're done with our work. We want our colleagues to see it. So we said, git push hyphen set upstream or -u, and we set origin, push to origin, and we gave it a name. We gave it the same name as over here, topic, but we really didn't have to. Okay, so we did a push, and what a push means multiple things. The first one is that the database was pushed, right? So these graphs were pushed. Okay, so it was like this: ABC2, okay, and ABC3. That's an ugly B. Hold on, ABC3. Okay, so the graph was pushed, which means the blobs were pushed and the trees were pushed. Okay, and then because we gave it a name and we called it topic, then two things happened. First of all, there was a pointer to it. Okay, topic. Okay, notice that the hat is there. The hat doesn't really matter. Okay, and also because we're now tracking this topic branch over here, we also have origin, origin slash topic. Okay, now what happened then was, we received some feedback, and our colleagues told us, to change a couple of things here and there, and so we created a couple of more commits. I'm going to create just one because I don't want to like waste your time. Okay, so let's say that, hold up, like on this. Okay, so let's say that we created another commit. Let's call it ABC4. Okay, like this. What did it do? Well, it moved the topic branch over here. It moved the topic branch over here, and it moved the head branch over here, like this. Okay, remove these guys. Okay, great. So what did we do after this? And by the way, notice that the origin topic is still at the same place. Okay, so the next thing that we did, we pushed again. This time we didn't need to do like push set upstream or anything. We just pushed. Okay, what did the push do? Again, same as before. First, it copied the graph. You know, I mean, first of all, it realized that there were no conflicts, right? But we're not going to talk about conflicts in this entire video. We're going to talk about them later. Okay, so just copied this over. It did this. Okay, it also moved the topic branch, right? Which is the topic. Okay, this is ugly. Hold on. Okay, so this is an arrow. Okay, and this says topic. Okay, which means I can go and I can remove this over here. Okay, and a push, it also did the synchronization, so it moved the origin head as well. I'm simply going to do like this. Okay, so that I don't have to redraw the whole thing. Okay, now at this point, what happened was that everybody said, okay, this is now fine. Let's merge it into the main because our pull request was from the topic branch to the main. Okay, now because there were no conflicts and because nobody did anything with the main, nobody moved the main pointer, then Git had multiple choices how to perform this merge. And I know that we haven't really talked about merges yet, but we're gonna see like parts of it real quick. Okay, if you remember, there was this big green button and there was a tiny arrow to right next to it, and we had a choice. We could say just merge it or force creation of a merge commit and so on. Okay, so Git has a concept of fast forward. So Git has the ability to look at this graph and to figure out that nothing changed. And so if you wanted to merge ABC4 into the main branch, all it would need to do would be to remove this pointer and simply point point main over here, right? This is called a fast forward because basically the main just moves to ABC4, to wherever topic is moved. Okay, but this is not how it's usually done with the pull request in the main. It's sort of done by convention. Most teams they prefer that another commit is created. Okay, this the so-called merge commit. Okay, so if you remember, actually, I'm gonna go over here. I'm gonna show this to you. So if we go // if we go to the repo second and if we do git log one line, this one, the one was the really long commit message. This thing happened on GitHub, and we had the ability there to change stuff, to change how it's called. Okay, so this is a commit that was created on top. Okay, so what happened on GitHub was that there was this so-called merge commit. It's a regular sort of commit, but it has like two parents. Okay, we're gonna call it ABC. Okay, hold on, we need to switch to black. So it's gonna be like ABC, whatever. Let's call it 5. Okay, and it points to this guy over here. Okay, and now it points over here. Okay, so it has two parents. It has the ABC4 and it has this parent. Okay, and now main simply moves to over here. Okay, main. Okay, so main now points to ABC5. Okay, so I'm going to remove this. This is what happened so far. And also another thing that happened is that if you remember, there was a button to delete the topic branch because GitHub figured out that we probably don't need it, and I pressed on it. And I also mentioned that I actually have a plugin that does this automatically. So let me actually go real quick and delete the topic branch. And again, deleting just means like removing this pointer. Okay, so we're gonna do this. Let me actually go and show you this plugin. What is this? Go away. So this plugin is called Refined GitHub, and if you scroll down, there is like a bunch of features, and one of those features is that it simply, probably this is what is shown over here, right? So it automatically clicks on this delete branch button, probably at option to wait for. Okay, no, this is the demonstration is about something else. In any case, this is what you always want to do. You know, as soon as the branch is merged, you want to delete it. Okay. So this is what happened over here, that it was removed over here. Okay, let me move it a little bit. All right, so what happened next? What happened next is that in our local repository, we wanted to figure out, you know, what changed, you know, what happened over there, right? Because over there on GitHub, it was merged, so we wanted to have these updates. So what we did was git fetch. Now, what git fetch did, first of all, it brought in the graph, right? So it did, like, this is always like the first layer, right? So it did like ABC5, and it did this, and it did that. And most importantly, what it does is it actually moves the remote branches. Okay, so the remote pointers. Okay, so now it's said that the origin main points to here. Okay, so this is now the this is an ugly arrow like this. Okay, so then it did origin main, and probably it also moved the origin head. Oh, come on, origin head is now here. Okay, so now we can go and remove this. Okay, also if you remember, we did also git fetch -- prune, and prune figured out that topic over here was removed, and so prune also removed this guy, right? Not this guy, just the remote one. Okay, fetch just moves around like the remote branches. Okay. Okay, what did we do then? We said, okay, let's go and do git checkout main, because we wanted to update our main. Okay, so we did git checkout main, which moved our head. Okay, so it just went over here and moved the head. Right, same as always, which means the head doesn't point to this guy anymore. Okay, and if you remember, the output told us that we are 1, 2, 3, 4 commits behind, and this is how it knew, right? Because we did fetch brought in the graph, it brought in the other pointers, and because we know that main tracks the origin main, it knew that, hey, you know, wherever we are, we're actually behind. Okay, and so what we did was we said, okay, well then do git merge origin main, right? So we said, update the main was the origin main, and usually you would do like git pull, and git pull would do the fetch for you and the merge. And if in case you remember, it is actually configurable if you want to do a merge or rebase or a fast forward, but we're going to talk about this some other time. Now, what is important to understand is that this is not the same merge as was happening over there, because over there we were merging ABC4 with main, and this commit was created. Over here, we're merging ABC1 with this ABC5, and so Git figures out like, hey, the whole merge already happened. All I need to do is I need to move this pointer, this main pointer. Because this is also where head points to, then both of these guys go over here, right? So they go over here. This is going to be the main now. And this is going to be the head. Points over here. Okay, so let's remove these guys. The head is removed. And the main is removed. Okay. And then we also went ahead and we said, okay, now there is no need for the topic branch. So we did git branch -d topic, and we removed this. And this is the whole thing. This is how we, this is the basic Git workflow. This is how we moved both repositories. And if you look at this right now, both repositories are now 100% in sync. Okay, so now if you want to create another topic branch and so on, you would just simply go and do this, and you know, you're gonna start from here, right? So if you're gonna create, you know, a branch for another topic, whoops, for another topic like this, right? So you're gonna go, come on, it's supposed to be green. You know, you're working on your next feature, so you're gonna do this. You know, this is like a topic 2 or something, and then you check it out, and then you move your head, and you know, the whole cycle repeats. So there you have it. In part 3, we did all of this with the GitHub CLI commands. I typed everything in the terminal, and now we drew the period picture so you know exactly what happened behind the scenes. Okay, and I have to say, this is a very, very beautiful and very elegant design. Before systems like Git, branches were something very, very heavy. And so this very elegant design is the reason why Git dominates the VCS game. And now I can also tell you how branches are properly defined in Git. In Git, a branch is a pointer. Let me actually create, let me actually put, hold on. I'm going to remove topic 2. Okay, so let's say for some reason there was a there was another commit over here. Actually, I don't need to draw it like this, right? I can just move this whole thing. Okay, where's my cursor? It's over here, so I'm just gonna move this whole thing. So let's say that there was another commit, you know, ABC6 or whatever, right? And we're gonna have like, I don't know, ABC7. Okay, and then we're gonna have some pointer. You know, let's call it, I don't know, topic 1337. Okay, the way branches are defined in Git is a pointer and everything that is reachable from that pointer. Okay, so technically a branch is, you know, this whole thing, like from here to here to here. And because it can go like this, and it can also go this way, because this other, you know, it can also follow this other pointer. So a branch itself is actually like multiple branches, which is again why this branch metaphor is weird. And so when you delete a branch, when you simply remove this pointer, unless you have written down somewhere the hash of, you know, the SHA of this commit, there's no way in hell that you can find it, because look, all the arrows that go backwards, they never go forwards. Right, so let's say like you know, you do git checkout main, there's no way in hell that you can find these two commits. Okay, so essentially a pointer is just like, it's, instead of you having to write down, you know, your hashes yourself, you know, your SHAs, you know, you simply create these labels, right? So the branches are simply like these labels, these pointers, and then that is all. And so to sum it up, when you do, you know, git branch A, you create a pointer A. If you do git branch D, you know, -DA, you're deleting the pointer A. If you do git commit or git merge, you're moving the currently active pointer, which is the one that head points to, and the head pointer itself. If you do git checkout, you only move the head, you know, and obviously the local database, you know, messes up your working copy. And if you do git fetch, then you're moving the remote pointers. Okay, so all of these commands, they're moving pointers around. And by the way, so far we have only discussed the commands that move the pointers forward. In the upcoming videos, and probably even in the next one, we're going to learn about how to move pointers backwards and thus rewrite history. All right, so let's go and play with git log actually a little bit. We're pretty much done with this video. Now, git log has two kinds of colors. The first ones are the ones that I tried to replicate. As you can see over here, you have the main pointer, the head points to the main pointer, you have the origin pointers, right? So as you can see, like, you know, we didn't push this commit, right? So the origin main points to something else. Okay, the other colors are the ones that are used to draw pretty graphs. Okay, so before we did, you know, git log one line, but we can also do graph, and then you're gonna see this. Okay, and so by the way, this should resemble our graph. It's just that it's flipped like this. And so the other set of colors that is used to draw this graph, these colors, they don't have any meaning. They were just like chosen sort of randomly. Okay, there's also a way to configure this palette, but we're not gonna go there. Okay, so as you can see, like there was an initial commit, and by the way, this is very important, right? The branch, you know, the topic branch, you know, the one that was called my awesome feature or bug fix 1337, right? This is just a message. This is why it's stored there. But like this branch was deleted, but Git somehow still can figure out how to draw this graph. Right, so you still have like branches even though like the pointers were removed, which is why like this metaphor is kind of confusing, and I really tried to avoid to confuse you. It can draw this graph simply because it looks at this guy, this commit, and it can see that it has two parents. We might actually be able to see this. Git show 49fc git show, hold on, 49fc. Okay, as you can see, okay, this is a parent, right? So it knows that this is a merge commit because it sees that there were two parents, this D09, which was the initial commit, and this one, 7B5E, and so on. By the way, you're always like seeing these pointers, you're always seeing these branches. And so essentially what I would like you to do, like as an exercise right now is, well, not right now, when you finish watching this video, is go through this typical basic Git workflow. Let's say you're you want to work on a topic branch, start with the main, make sure that it's up to date, create your topic branch, switch to the topic branch, make your changes, make a couple of commit, push this branch upstream, get your pull request merged, fetch the changes locally, go to main, merge the origin main, or you can do like git pull instead of fetch and then merge, do git pull and all of these things. And while you do this, every time run git log one line graph and watch how these pointers are jumping around, and they should jump around exactly how I drew this picture. Also, you might want to rewatch the third part of the series now that you have these pictures in your head. And yes, pun intended, because head. Now we're pretty much done with the main portion of the video. I just want to mention a couple of very, very important things. The first one is that notice how it seems like head is always pointing not directly to a commit like these guys, for example, right? But it always points to some other branch. Well, what happens if we do git checkout and like a random commit somewhere in the middle? Like for example, this one, 5A32. Let's actually go and do this. We're going to do a git checkout and we're going to say checkout 5A32. Like this. Okay, so we're seeing over here is that it says switching to 5A32. You are in a detached head state. And I remember the first time I saw this years ago, I was like so scared, like what the hell, where am I? Okay, you can look around, you can make experimental changes, and you can actually even commit them, right? So every time you're going to commit them, you're going to move the head along with you. Okay, and you can discard any commits you make in this state without impacting any branches by switching back to a branch. Now this is interesting, right? And we're going to do this in just a second, right? So first of all, let's actually do git log one line graph. Okay. So it's gonna show it to you like this, right? So the initial commit, then like summary, and then summary. Okay, so this is the third one, right? Summary, and now we're over here. Actually, no, hold on. No, 1, 2, 3, 4. Okay, so we're this one. Okay, so this is what we've seen: 1, 2, 3, 4. And by the way, there is also another flag that you can use, which is all, because right now, like again, remember a branch is, and currently like our branch is sort of had like there is no branch, there is no pointer. But the way the branch is defined is like everything that is reachable. And for now, everything that is reachable only these four. But you can also do all, and you're going to see the entire graph. Okay, so as you can see right now, our head for some reason is like over there because we said git checkout over there, but it doesn't point to like any branch. There is no branch. Okay, so this means that we're gonna read the rest of this, by the way, later, or maybe not. Let's read it now because I'm gonna forget it. If you want to create a new branch to retain commits you create, you may do so now or later by using -c with a switch command. Remember, so git switch -c, it creates a branch and switches to it. It's the same as git checkout -b in some branch. Okay, or you can undo this operation with git switch hyphen. So this hyphen is it just switches back to the main, right? So that's just behind the scenes it would do git checkout main or git switch main. Okay, because we came from there. Okay, and you can also turn this advice off by setting this thing. I don't recommend to set this advice to off. Okay, so what we're gonna do now is we're gonna go and we're gonna say git branch, and it's gonna say had detached at this commit. Okay, that's weird. Okay, let's do git status. Same thing, had detached at blah blah blah, nothing to commit. Let's create something to commit. Let's just add a new line to the README. Like this. Okay, let's do git status. Let's do git add. Right, we're all in this like detached state. Git status. Okay, git commit -m adds new line to readme. Okay, let's do git branch. We're still detached somewhere, right? Let's do this, git log thing like this. Okay, now it looks weird. Okay, so remember our head was like somewhere in the middle over here at 5A32. Now we created a commit where we said adds new line to readme, and which is over there. Okay, so this commit is this star over here, right? So we created another one, so our head is over there. So what we can do now is we can simply create another pointer, right? So that we don't forget where we are. Because if we do like git checkout main, and this is exactly what this text said, it says you can look around, make experimental changes, and commit them. And you can discard any commits you make in the state without impacting any branches by switching back to a branch. Because if we switch back to a branch, like if we do like git checkout main right now, nothing has this thing written down. So we're gonna lose this pretty much, right? We will have no way to get there because remember all the arrows go backwards, not forwards, right? From here, we don't know how to get there. We only know how to from there to go back here. Okay, so let's play nice. Let's actually go and say, git branch, and we're gonna give it some name. Okay, so let's do git log now. Okay, and now notice that the head points to some name, and so if we do like git status, it doesn't. Okay, it still says that the head is detached because notice that there is no arrow. Okay, so the head points to the commit, some name also points to commit, but there is no arrow from head to some name. Okay, so we still need to do git checkout some name. Okay, and now we're properly switched to this branch. So if we do the git log thing, we're going to see that there is an arrow now, right? So we're not in a detached state anymore. We simply gave it a name, so now we're not going to forget it because it's so important to understand that had we not done that, we would have lost it. We'll actually go and do this again. So we're going to do the same thing. We're going to do git checkout. What was it? 55832. Yes, this is the one that we want. Okay, so we're going back to exactly the same one. Okay, what's happening? Somehow it hangs. I have no idea what is happening. Oh, it's probably my Windows terminal. Okay, let's go in there. Windows terminal, go in there, cd dev repo second, git status, where are we? Okay, we're on some name, git log, one line, graph. Come on, graph, all like this. Okay, so this is where we are. Oh, I did it like this, right? So that the whole thing fits. Okay, so let me just do this. Okay, so I wanted to do git checkout. What is it? 5832. Okay, so it gives us the same thing, right? So git log one line graph. Okay, so we're somewhere over here, or head for some reason is over there. It's completely detached. Okay, so we're gonna do the same thing, echo new line. Okay, so we're gonna do this, and now we're gonna do git add dot. Okay, git commit -m, adds. Maybe we can do control R, new line. Okay, it lost it. Okay, git commit -m, adds new line to readme. Okay, like this, and let's do git log again like this. Okay, so there we are. Our head is now over there. Okay, so what we do now is we're going to simply go and do git checkout main, and we're actually going to get a warning. Now notice, first of all, it actually did it. Okay, it gives us the warning, but it actually did it. It switched to branch main. Okay, so it says warning, you're leaving one commit behind, not connected to any of your branches, right? Because the pointers go, they point backwards. Okay, so it says this 44D, which is this one, add new line to readme. If you want to keep it by creating a new branch, this may be a good time to do so with git branch. We create a branch, and by the way, this is like we haven't seen this so far. Like usually we would say git branch and create a name, but you can also create a branch and point it to some commit because it's just a pointer, right? You can say create a branch that points to like that thing, okay? Not to the current one, where the hat is, okay? So essentially, if I clear the screen or if I close my terminal, this thing will be lost forever, right? There is no pointer that points to it. So if we just do git log one line graph all, we're not going to see it anywhere, right? Because there is no pointer to it anymore, right? So this one 44D, it's just not there. So we lost these changes, and this is exactly what the text was saying. You can make commits and whatever, but as soon as you switch to another branch, you're going to discard all of them. And by the way, we're going to talk about a thing called garbage collection in Git now. So Git creates a lot of garbage, and from time to time, by default, I think when it reaches 6,700 objects, then the garbage collection will run. And it will remove all of these things because we created a commit, right? So which means we created a blob, we created potentially a tree, we created a commit, like all of these objects. Now because nothing can reach them, they're garbage, right? So eventually they will be cleaned up. Okay, so what happens if you do something like this accidentally? Well, in this case, all you need is a little bit of luck. See, Git has a special thing called reflog, which logs where your head has been, right? So technically it's a reference log, but it only logs where head was. Okay, it's actually funny. Like the first time I learned about it years ago, I thought it's pronounced reflog, but no, it's ref log. It's a reference log. You can look into it by saying, git log -g, but this -g is not. You cannot always mix it with like these others, and so I never do git log -g. I just always do git reflog. Okay, so it shows us basically where the main has been. Like in as you can see, we don't even see. I know we actually see the beginning, right? So there was a clone that we did a checkout, so we moved from main to main. When you mess something up, you look into reflog, and reflog will save you a butt. But all the logs, they cannot be allowed to grow unproportionally. So from time to time, the same mechanism, the garbage collection of Git, will go into this reflog and prune it. So usually it's kept around for like a couple of months, or maybe it actually participates in this 6,700 objects count, right? So as soon as it reaches more objects than this, then it's going to be cleaned up. But actually, I think that the timer for this is handled somehow differently. Okay, so I think like every couple of months it just pruned a little bit. Okay. So as you can see over here, this is where our head currently is. We said git checkout main, but before that, we moved from this commit. This is the one that we sort of forgot, but we didn't forget because there is a special place called reflog that keep track of it. Okay. And so it basically it shows us over here, right? So this is the hash. So we can do git checkout this thing, or we can actually go and do git checkout, and we can use like this is also like you can use this as a pointer. By the way, if you're reading through the manual pages of Git, very often they're referring to a thing called ref spec, and this is basically like all the things that you can refer to. So like this is not a pointer, but this is a ref spec, so you can refer to it. So you can do git checkout head at, and you just do 1, okay, and then it's just gonna go there. Okay, that says switching to head, blah blah blah. You're in detached state. So if you do like git log one-line graph, you're gonna see that we're back at this thing, and so now you can you can create a branch. You can save it. Okay. So we can do git checkout -b, which creates a branch and also points the head to it. We're gonna call it like I don't know, some branch or something like this. Okay. And by the way, which also reminds me that if you remember from the first videos that this thing, this -m that moves the master to main, this is how you can rename branches, right? So you can do git branch -m, -m, and you can give it like some other name. Okay, so right now it was called some branch, but if we do it like this, now it's called some other name. Okay, and by the way, we're moving dangerously close to like rewriting history, because like if this branch was already pushed, you're opening yourself to a world of pain. Okay, so like all of these like rewriting things and like moving pointers backwards that we haven't discussed yet, but like this one is already like a little bit too close, right? Renaming a branch is like it's like doing something backwards. Okay, and so these things, they're all fine and dandy, and they're really, really awesome when you do them locally, but as soon as they're pushed, you have to be very, very careful, right? Because if you push, somebody might have pulled, right? And then synchronizing that is going to be very, very painful. All right, now the only thing that is left to discuss is the the security concerns that I mentioned in the beginning of this video. And in case this video got too long, I actually split it up into two, so it might have been like in the previous video. Okay, now before I said that SHA-1 is a cryptographic hash, which means that it's just a 40-digit hexadecimal 40-digit hexadecimal number. But obviously there's more to it. Okay, so what it is essentially a fingerprint of data. And the purpose of it is efficiency, right? So let's say that you have a bunch of movies laying around on your hard drive, and all of them are huge because 8K, HDR, whatever. And let's say that you have two movies that are very, very similar to each other, right? One is like the regular one, and the other one is like director's cut, and both of them are like 100 gigs large. And you want to like figure out like which one is which. If you wanted to do this like programmatically, without like looking at names, because like I don't know, your brother renamed them, right, or whatever, right? So if you want to do this programmatically, you would potentially have to go through gigabytes of data, right? So each of them is 100 gigs, and the majority of those bits, bytes and megabytes and gigabytes, the majority of them is the same because it's the same movie, right? The other one is just a director's cut. Okay, and so a hash can help you to fingerprint them, and then you can compare the fingerprints because the fingerprints are much smaller. Okay, so you calculate the hash of the first one, calculate the hash of the second one. Usually these functions that calculate the hash, they look at, like, I don't know, the size of the file and whatever. They have, like, they're very advanced. Okay, and then you have like these 40 digits that you compare to each other, and it's very fast. Now the quality or the strength of these hashing algorithms, or of these hashing functions, is judged by the variance in the distribution of its values. So for example, like, these movies are very similar. However, the hash should look very different. Also, like, even like if you have like two, not even movies, if you have text files, and both of them look like exactly the same, but there's like 1 bit difference, the hash cannot look just like, I don't know, +1 or something, right? The hash should look like a completely different number, right? So the value should be distributed as much as possible. This matters because the attacks on hash functions are the so-called collision effects, right? So the attacker, it would try to create a file which is different from the original one, right? But it would create it, they would create it in such a way that it would hash to the same value. So they would create a collision in this hash function, right? So the value that comes out is going to be the same, but even though the file was different. And this way you could potentially sneak something like a virus into an open source project, right? You would just commit a file that, looks like their regular file, because it hashes to the same thing, but actually behind the scenes it has some malicious code. Now, Git was created in 2005, and ironically, theoretical attacks against SHA-1 were known even back then. In 2017, these attacks became practical. The so-called Shattered attack was introduced. Shattered because SHA and turd shattered. These attacks, they're practical, like, to people who have money, because you still need like a computer that can crunch out a lot of numbers. For instance, these days an attack on SHA-1 would cost you around 100K, but recently with the election and the riots and the pandemic, the dollar tanked, and so 100K is not what it used to be anymore. In any case, Git improved the algorithm, which improved, on the so-called Shattered attack. It's still possible, right? So it mitigated the damage, but it is still possible. And also, last year, or technically 2 years ago, in 2019, there was another attack on SHA-1 called the chosen prefix. So yeah. Now, the simplest way to improve the situation, and I'm saying simplest, but it's actually not so easy to do. It's simple, but it's not easy. There's a big difference. Okay, the simplest way to do this is simply to use an algorithm which uses larger keys, right? So not just 40 digits, but more. And pretty much ever since then, like even before 2017, Git was working on a solution for this, and they're sort of like moving to SHA-256. Now, I'm recording this video at the very end of 2020, and it's going to be released at the very beginning of 2021, but it is still not ready for prime time. There is already some experimental stuff there, and I'm going to show it to you, but please only do this at home. Do not do this at work. Okay, so we're going to go over here, we're going to go up, and we're going to create a directory. We're going to call it experimental. Okay, so we're going to do cd into experimental, and we're going to do git init, and we're going to pass it a flag called object format SHA-256, like this. All right, and we didn't specify that the initial branch should be called main because we have the global settings now. Okay, so let's go and create a new line in a file that doesn't even exist yet, readme.md, git add everything. Let's also look at git status, and let's do a git commit initial commit, like this. Okay, so now if we do git show, we're going to see that this number is now much larger. Now, there are obviously plans to do this for for the existing repositories and stuff, but it's a huge migration, so it's gonna take a while. This is experimental for now. Again, please only do this at home. In any case, I know that some of you are paranoid, so you're not going to listen to me no matter what I say. For the others, calm down. Nobody's going to try to create collisions in your Hello World project. Okay, chill. One very last thing that sort of slipped through the cracks are the tags. Tags are not very exciting, and we might stumble on them again in the upcoming videos. Essentially, tags are pointers that are not moving automatically, right? So you have to move them manually. You have to push them manually. Also, there are two kinds of tags. One are sort of like a little bit heavier. They're sort of like commits. They have more information about the author and stuff. Okay, so let's actually real quick just go into the repo a second and do the whole git log thing like this. Okay, so let's say that we wanted to tag for some reason like this commit over here, right? We would just do a git tag. We would call it version 1.2.3, and we're gonna say 5832 like this. Okay, so let's go and look at it. And as you can see, there's a tag now. We can also use it as a ref spec, right? So we can go and we can do git checkout v1.2.3, and we're now in this detached state because we know we tagged the commit in the middle of nowhere. Let's actually go and do git checkout main because we don't really care. Okay, so git log. Okay, everybody's happy now, right? But this tag is now in the middle of nowhere, so if we go there, we're going to be in this detached head state. One intriguing thing to know about tags is that GitHub has a concept built on top of tags called releases, right? So Git doesn't have releases, but GitHub does. So if you go to some repository like even ours, we can go over here and we see the tags, but we also have like the releases tab, and we don't have any releases. Okay, so if we go to some I don't know, GitHub Scala. I'm just gonna grab like a regular, some random repository. Okay, so if we go to, so first of all, we have like tags, like most tags, they contain versions anyway, and then you create like a release, which is it's like a tag on top of a tag. So if you go releases, you see like over here latest, and you have like 60 releases. Okay, so over here you also have you have tags, and you have the releases, which basically just point to some tags. Like as you can see, there's a tag behind it, right? But release is a GitHub feature. It's not a Git feature. All right, now I know that this was a lot of stuff, but this was also like the most not well probably like the most intense in-depth video to like under the hood. And so everything that we do from now is actually going to be easier. Even the rebases, usually people find like rebases complicated, but as soon as you understand this, like everything becomes much easier. And I love rebases. Rebases are awesome. Like once you're going to learn about them, you're going to use them all the time. In any case, I'm blabbering at this point. I'm going to see you in the next one. And for now, as always, it's been Vlad, devinside.com. Don't forget to like this video if you did. Commit if you want to improve the developer inside you. And when I say commit, I mean subscribe if you want to improve the developer inside you. And if you learned something today, consider supporting me on GitHub sponsors or Patreon, whatever you prefer. And just watch my videos weeks and sometimes even months before everyone else. And most importantly, take care.